about to demonstrate how the app works for acid-based titration. Once the student enters his or her login details, the student will come to this environment and click the experiment of his or her own choice. On the left-hand side of this app, we have about 9 experiments. So for this demonstration, we are going to work with acid-based titration. So the first thing is for the student to enter the laboratory, then run experiment 1, then you click. Some values are given to the student in which the student will use to do calculation. The pipette volume is 50 cm3. The base weight, that's the salt, is 29 grams. The total base volume is 500 cm3. Then the equation of the acid to the base. And some instruction is given to the student on how to use this animation. It says click on the apparatus, on an apparatus from the apparatus bar located on the right and the left or bottom of your screen. But for this experiment, we don't have any apparatus on the bottom of the screen. Then click the lab table to animate the next step. So this is how to use the app. For somebody using this app for the first time, we have instructions to follow. You click instructions and you see steps to follow. For this titration experiment, the first step is to click the beaker to the lab table, then the alkaline bottle, then the third one is the pipette, fourth one the conical flask, fifth measuring cylinder, sixth acid bottle, seventh we have burette mounted, the eighth is the funnel, the measuring cylinder, the ninth step, the 10th step, funnel burette removed, 11th, conical flask filled, then pH indicator, 13th, conical flask mounted, then the 14th step, which is the last step, is titration. So we close and start. So I click the first step, you click the beaker, and click the lab environment. You click the lab environment by bringing in your apparatus. Then we click the alkaline to be poured into the beaker. You also click the lab environment for that to be done. Once this is done, you click the pipette to take some known volume of alkaline from the beaker. The fourth step from the instructions is to click the conical flask. You click the lab environment. This is for you to pour your content from the pipette into the conical flask. The fifth step is to click the measuring cylinder to the lab environment by clicking the lab environment. Then the next step, which is the sixth, is to pour acid into the measuring cylinder, and that is done by clicking the acid and clicking the lab environment. The seventh step is to bring the burette to the table to be mounted on the burette stand. So we click onto the burette, then we click the lab table for it to be mounted on the burette stand. The eighth step is to insert funnel into the burette. You click funnel, then the lab environment for that to be done. Then the next step is to click the measuring cylinder field. When we started, it was just measuring cylinder, but now because there is some content of acid in this measuring cylinder, it's written measuring cylinder field. So the student will click the measuring cylinder field to the lab table to be poured into the burette. The next step is to remove funnel. Here we are seeing funnel remove. Initially it was just funnel, so it's instructing us to remove funnel. So we click funnel remove and we click the lab environment to remove the funnel. Then we bring the conical flags to the base. So we click the conical flags field. It's filled now because we have some alkali in the conical flags. You click it and bring it to the lab table. The next stage is to add some drop of pH indicator for color change. Then we click pH indicator and we click the lab table. Some drops will go into the conical flags and we see that the color will change to pink. Then we have to put the conical flags under the burette, to be mounted under the burette. So now we have conical flags mounted. So we click the conical flags to be mounted under the burette. To prepare for titration. Then the last stage is to titrate. So we click titration and we click the lab table. The titration will not start until the student click start button. So the student will click start button and keep watching until the color changes. Once the color changes, the student must click stop. So for us to start the titration, we click start button and watch for color change. So the student is watching for the color to change. So the burette volume for the experiment 1 is 247 cm cube. Then we close it. Then we click run experiment 2 for the second run. This time around, the student will not start the experiment from the beginning as he did earlier. You just start titration by clicking start button, then you wait for the color to change. Once the color changes, the student must click stop. (241.7) for the second experiment. So we close for the third experiment. We click run experiment 3. Then the student clicks the start button and wait for the color to change. The student is waiting for the color change. So the third title volume will be seen after clicking show results. So the student will click show results. The third experiment is 247.04. So the student is expected to calculate the average title value. The average calculated by the student is 247.03 cm cube. So the student is expected to calculate the acid molarity in mole per dm cube. So the student has calculated the acid molarity to be 0.293. The student is also expected to calculate the base molarity in mole per dm cube. The student has calculated the base molarity to be 0.73. 0.73. So the student is also expected to calculate the base mole. This calculation of the base mole is based on the base volume, that is the 500 cm cube. The base molarity is calculated to be 1.45. And the acid moles is calculated to be 0.293. Then the calculation of the base mole is based on the total base volume given, which is 500 cm cube, and is calculated to be 0.73. Acid mole is 0.072. Okay, so the student is expected to submit its result, its calculated result. So the student will click the submit button. Here we have the student's result and we have the experiment. The app is designed in such a way that it will help the student do the calculation based on what the student provided as the average titer volume and based on the standard given. So if we compare it, the average titer volume is calculated by the student to be 247.03, but the system helps the student to calculate it as 245.25, and the student also calculated the acid molarity to be 0.293, while the system helps the student to do the calculation based on his own experiment at 0.296. Then the base molarity, the student calculated it to be 1.45, which means the student is correct. We have 1.45 here calculated for him. Then the base mole, the student calculated it to be 0.73, which is almost correct. The system helps the student to calculate it based on his experiment at 0.725, which can also be rounded up to be 0.73. Then the acid mole, the student calculated it to be 0.072, and the system helps the student to calculate at 0.0725. It's almost there. So the next stage is to print report. Once we print report, the system will now, the app will have its actual value that will be compared. That's what the app expected the student to produce. The result the app expected the student to produce will be compared with these two. So we click print report for the comparison. Okay, the actual is what the app expected the student to calculate. What is expected of the student is what is actual, and it is 241.667. Okay, student experiment is what the system calculated based on what the student got from his experiment, and is calculated for the student to be 245.247, while the student himself calculated his average titer value to be 247.037. So we have some percentage error here. The student calculation has 2% percentage error based on calculation if we compare it to what is actually expected. And what is calculated for the student based on what the student provided is 1% error. Okay? Then the acid burette molarity. The app actually expected the student to calculate it to be 0.300. The calculation for the student based on what the student provided that the system helped the student calculate is 0.2 0.96, while the student himself calculated it to be 0.293. And here we have, they both have 1% error, 1% error, 1% error here. Then the pipette molarity, the actual that is expected from the student is 1.45. The system calculated it for the student as 1.45, and also the student also calculated it as 1.45. So it's 0% error when we compare the two with what is actually expected. Then for the base mole, the system calculated, the app expects the student to have 0.725, and the system helps the student to calculate it based on what he provided as 0.725, which is correct, so it's 0%. But the student calculated its own to be 0.730. So the student will still have 1% error. So the acid mole, the actual that is expected of the student, is 0.073. And the system calculation based on what the student provided is still 0.03 with 0% error, while the student calculated his own to be 0.072 with 1% error. So this is how the demonstration goes.